Testing, testing, 1, 2, 3. So, 2 people decided to show up today, huh? Is it because it's a Friday, or is it because everybody has another test, I wonder? Well, anyway, better get started, I suppose. No point in waiting for these lollygaggers. So, when last we spoke, we were talking on the subject of databases. We were learning how to do SQL queries. It's all very exciting. So, this will be a continuation of that lecture. So, we had, to my memory, discussed schema. We had discussed how to construct a table. We had even discussed how to put data into that table. So, let's talk getting data out of tables. So, with SQL, when you're querying data from a table, querying data like this is often going to be the easiest way to actually see the contents of the table. It's not necessarily going to do it just to open up the database in a text editor and, scan through. Kind of the whole point of making a table or making a database in the first place is that you don't have to manually go through all of these files worth of data all by your lonesome. You have some ability to query, hence query language. So, let's review a few things that you can get, a few things that you can query. But before we do that, let us establish in our SQLite instance right here. Let's establish that we are opening and viewing moviestore.db. There we go. So, in order... there we go. So, in order to see everything in the table, we're using asterisk as a wildcard character. Select is the operator. So select all from whatever the table name is within the database. So, although we haven't quite seen it yet, databases will often have multiple tables to store various things. Some tables, the only purpose of them will be to relate one piece of data to another. So, from movies, there we go. And you can see what the state of our database is. So, if you're only interested in a couple of fields from your table, you can specify which fields that you want to see. That where we're using this wildcard star character, that's where we select which fields we want to see from the database. So when we use star, we mean show us all the fields. However, it is certainly possible to be more restrictive. So, select title and rating from movies, and you can see it gives us back only the title and ratings of the things in our database. There. Oop, Jesus Christ. There we go. All right. Good. If you want to be a little more selective about the entries that you see, you can actually apply sorting to them in a very similar manner to how you might apply a Boolean condition to data. So, if you want to narrow it down, you can use the where clause and then specify some condition. In this particular case, genre is comedy, semicolon. The only thing that we get is Life of Brian, which is a comedy. So this is good. However, using this syntax, we are doing exact matching. And as you can tell from the manner in which these genres are told, or encoded, I should say, it's entirely possible that you want to search for all of the comedy movies, all of the movies that are comedy and some other genre. This becomes particularly important the more information that you're packing into a single field. So, there's what we call fuzzy matching, and we're going to introduce wildcard characters once again in order to do some fuzzy matching and get all of the movies that have comedy as a genre, not just the ones that only have comedy as a genre. So rather than use equals, you use like, and before and after the string that you'd like to do fuzzy matching on, you put the %sign character in. This is the in-string wildcard character for SQL queries. So if you enter that up, then you can see we get Back to the Future and Life of Brian, which are the only two things that are comedies in our list of movies that exist so far. And of course, if you are interested in organizing the data in a little bit, organizing the order in which the data appears, you can in fact also sort the data. In order to sort the data, you use the order by clause, and then you give it the field that you want to order by. So let's say, for example, rating. You then have a choice of choosing ascending order, descending order, or do not specify an order, which defaults to ascending order. So there you go. That's how to query a table. Yes. And the next few slides are the things that I just did in that terminal, so we're just gonna zip through. So let's move on to how we might actually go about using these SQL queries in Python. It's important to understand that SQL is a different language than Python. However, Python is a very general purpose tool and can be used to execute code from other languages. One might not think of SQL as being a sort of fully blown language in its own right. However, you'd be surprised the abstraction tools that are made available to you. So, this is what we're going to do. We're going to follow the same basic idea, the same basic pattern that we used when we were writing and reading both CSV and JSON files. We're going to, first of all, import the relevant library. Next, we're going to read in the relevant file. then we do something to it, and of course, we always close our file handle when we are finished. So, let's take a look, shall we? Opening up my local Jupyter instance. Nope. Where is it? There it is. Good. You can see we've got a new movie store database already in here. However, can't be read. Accordingly, it's not UTF-8 encoded, so it can't actually be read by Jupyter. However, we can interact with it as if it were a database, which it is. So, the first thing that we need to do is import SQLite3. Next, we need to connect to the database. So database, this will be our database handle, is equal to SQLite3.connect. Video store dot. Actually, what did I call it again? Movie store.db. Good. So, after that, we do a bunch of stuff. Comment do a bunch of stuff. And then, of course, we close our database. So, it's important to note that SQLite will perform a certain number of conversions for us for free. Nulls and nuns are equated, integers and ints, reals and floats, texts and strings. However, the sticker is date. In the Python interpretation of the date type in SQL is a string. So if you want to read it into the datetime class or anything like that, you're going to have to perform that. Parsing or generating manually using the methods that you find inside of the datetime class. But, such as it is. So, kind of reasonably similarly to a file handle, there is a object called a cursor object, which the SQLite 3 module uses in order to iterate over a database and execute commands in much the same way that we would a file handle. So it's interesting because it's separate from the actual file handle that the database is associated with. So we shall call it cursor is equal to database.cursor. Then we can do stuff. Cursor.execute. So the execute method takes a SQL query formatted as a string. So an easy one is select star from movies. And it executes that command over the database. Then, once it's finished, the results of that query are stored inside of the cursor object itself. So we can access the stuff that's inside of cursor by using either fetch1, which of course fetches one record that has been read from the database, or fetch all, which of course fetches all of the things that have been read by the database. So you can see right there, our first entry is Casablanca, then Back to the Future, etc., etc., etc. Notice that the first entry is a tuple and the rest of the entries are inside of a list. This is because fetch all returns all of the entries as if they were inside of a list. Each record is a tuple. So that should be reasonably straightforward. it turns out that the execute function also generates something that's iterable as a return value. So if you catch that return value, you can, in fact, iterate over that return value in the same way that you would iterate over anything else by using a for loop. For row in rows, print row. And you can see that we have just all of the tuples that are contained in the database printed out one by one. Good. So, if we specify a particular value inside of the database, we can tell the database how to interpret things so that what you're actually getting out is a bunch of dictionary-like objects rather than a tuple. This allows you to access the various elements inside of the returned record by tag rather than by index, which might be very useful in certain situations. So, for example, if we insert right here db, notice this has to be after the creation of the db object, row, but before its use, logically enough, sqlite3.row. So you can see we have a bunch of row objects, which do not have a string interpretation, which is a little bit inconvenient for the purposes of show and tell, but you can always address them by tag, which is reasonably useful. So, if there are any human beings in my class at all who are in the chat, would you mind saying hello so that I feel so I don't quite feel like I'm just, pouring my heart out into the void here? It might help me distinguish people who are listening from bots. Well, at any rate, I suppose the lecture has been bought and paid for, even if it is has no live audience at the moment. So, with respect to this execute function, you can actually execute any manner of commands. Any valid SQL command can be executed using the cursor object. So, let's try to add something to the database. And funnily enough, I'm just going to comment out this stuff. Funnily enough, when you're doing things in Python, you don't necessarily have to have everything. Hello, thank you, Sydney. So, this one's for Sydney. The really cool thing about formatting SQL queries inside of Python is that you have the full expressivity and generative capability of Python at your disposal for the purposes of creating SQL queries. This is something we in the biz refer to as meta-programming. That is, the programming of programs, applying techniques of programming to the code of programming. Very, highfalutin, hoity-toity stuff that's well beyond the scope of any first-year programming course. But, the important point is that you can assign a bunch of variables. So let's say m is 17, t is the beauty, beoati, and the beast, the beats. There we go. And the genre will be animation, musical, comedy, romance. I'm adding romance because I think it's stupid that anybody who doesn't consider Beauty and the Beast a romance is stupid. It's a romance. And it's also G-rated. So, when we execute our command, we can actually perform the following. Cursor.execute. We can format our command. Whoop. No, don't execute it yet. Good lord. You can execute. You can format the command. We're going to be inserting into movies values. See, you don't actually have to, if you're using all of the things in the schema, you don't actually have to state the schema each time, which saves you a certain amount of time. But if you throw in a bunch of these question marks inside of a tuple, the method is intelligent enough to scan through the command that you have given it, check for these question marks, and insert into those question marks the values of whatever you give to it as the second argument in the form of a tuple. So if we give it all of these things that we defined up above, then there you go. Incidentally, if you are making changes to a database, then you should commit those changes. Otherwise, they won't be saved. So, execute, and I have got an attribute error. Am I missing something? Has no object commit. Oh yeah, I ran into this with the other class too. I don't know, they must change the name in it or something. But at any rate, perhaps we can, is it like save? Does save do it? It would make sense if it was save. Nope. Okay. Anyway, enough noodling around. So, if we were to then execute the read everything from the database, you can see that, let's just blow out that thing where we're making everything a row object so we can actually read what we're doing. You can see this new entry that has been added to the database. Cool. So, this is good. So, from there, let's go back into databases and how they're organized. Let's suppose, just for the sake of interest, we want to keep track of which customer at our video rental store that we inherited from our uncle, which customer has which movie. We will add a table for rentals to keep track of a relationship between customers and movies. So, let's imagine that we have the following. We have a table. Let's actually make this. So, within our SQLite database, let us create a table, customers, with the schema customer ID, which is an integer and a primary key, a name, text required, because everybody needs a name, and address. Text, address is not required because we do not discriminate, and we also rent to homeless people. There we go. So, now let's quickly insert a few of these just for the sake of interest. So insert into customers, values, 101, Dennis Cook. Oh, that should be in quotations. And the address is 123 Boardwalk. That's should be Boardwalk, not Broadwalk, because it's a Monopoly reference. There we go. Next, we shall insert Doug Nickel of 456 Park Place. Oop, sorry, that's got to be 102. There we go. And 103 Randy Wolf of 789 Pacific Avenue. There we go. So, select star from customers yields all of the data that we've entered. Yeah, relatively straightforward. So, again, we took the first 3 of those and did that. Now, let's create a table which contains the movie customer relationship. So, let us create a new table. As gods of the old world, we shall rend the cosmos in order to create and bend the world to our wills. So, we need a customer ID, which is an integer required. We need a movie ID, which is an integer required. We have a date rented, which is a date, and a date due, which is a date as well. Although hypothetically, the date rented or the date due could be calculated from the date rented. There we go. So let's insert into our table a few of our entries. Insert into, what do we call this? Rentals. Values 103, 104, 3/12, 2020, sure, and 3/13, 2020, and do the 20. Let's give until the 30th. Okay. Syntax error. Yes, I put a period instead of a comma. There we go. All right, and let's, just to make sure that everything looks good, let's select star from rentals. And there you go. That is all of the things. You'll notice that date is formatted kind of weird, but, you know, maybe it has to be in strings. Yeah. Ha! Should have been in strings. All right. Well, we'll just leave it like that. It doesn't really matter. So, given that I made a mistake, I think it's important. I think it'll be like conducive to a lecture with good flow to show you how to undo a mistake. So, if you want to delete a specific entry from a table, the way that you do that is you use delete from for example, rentals, where movie ID is equal to 103 or 104. And so if you take a look at the table, you'll notice that that entry has been removed, as you might expect. However, Sometimes the goof up is so big that you have to delete the entire table, so then you use drop table movies. Which, since this has been borked up so badly, let's drop table rentals. There we go. And now, if we try to select star from rentals, there is no such table. So there you go. So let's just quickly go back and put all of that in place. Our first entry, not forgetting the quotes this time. Oop. I said not forgetting the quotes this time. Entry 1. Entry 2. And entry 3. Taking a look at the tables. And there you go. Simple as that. So, my God, there we go. Okay, so the problem that we have here is that not all of the data that's pertinent to the renting of a movie is contained within the rentals table. We need to be able to cross-reference other tables in order to find all of the information that we need for, who rented what movie and what was the movie and when was it rented. So, what we could do is we could sort of naively use select to look up each customer one at a time. But let's do this a bit more intelligently, because we try to be intelligent people. So, there we are. So, when we do our select this time, until this point, we have been specifying only one table that we are selecting fields from. However, in this particular case, we want to have rentals and customers as tables that we wish to read from. So, we select all fields from rentals and customers. So let's see what this does. So what it does is it simply takes all of the values in the first table, puts them up against each one of the other ones. See how we've got repeats here? We've got 9 entries in total. It's kind of like binary counting, really. We've got Dennis, Doug, Randy, Dennis, Doug, Randy, Dennis, Doug, Randy, and we've got entry 1, entry 2, entry 3 for 3 times each. This is obviously not what we're looking for. It's simply multiplied these two tables together. So let's narrow it down. Where customers dot customer ID is equal to rentals dot customer ID. So what this does is it says, okay, the customer ID field from customers has to be equal to the customer ID field from rentals. So when it does that, you get only you get basically all of the fields for both tables run together. And this line above, where we have iterate everything else out, essentially. That gives you some insight into the manner in which SQL is generating this. It tries all possibilities and says, okay, but I'm assuming the user is going to narrow this down somehow, which is an interesting way of going about it. Notice that one of our rentals didn't actually happen, or one of our entries into the rental table didn't actually find any corresponding values. You notice we've got 1, 2, and 3 as valid customer IDs that actually exist in our customer table. So if it didn't find a corresponding customer in the customer table, then it just did nothing, essentially. Didn't show anything. So, yes. So the result, in summary, is if we had a single table with the rows from each table joined together when they matched the customer field. This is also called a join operation or an inner join operation. So if we wish to go one step further and integrate the movies database into this at the same time, we can say and, although it is a good idea to put this, it's always a good idea to start putting things in braces when you start introducing complex Boolean expressions like this. So we also want movies.movie ID equals rental.movie ID. And since we're using and referencing the movies table, we should include it up where we specify which tables we're referencing. There is no, oh, yes, this is true. It is rentals. There we go. And there we go. So we have not only the due dates of the movie rental, the name of the person renting the movie, but we also have the specific movie itself, and I can see that was the one we decided to leave the name out of. So, given that we left the name out of that one, let's update it. So, we can update fields in one or more rows using the update command. Oh, this is something else then. So, first of all, we need to specify which fields should be changed, and next we need to specify which rows the change should apply to using a where condition. So, if, for example, we wanted to update movies, we want to set the title of title to, oh, what was the name of that thing that we skipped? Come on. There it is. Field of Dreams. And it was PG. PG. Where movie ID is equal to 104, semicolon. If we select star movies, star from movies, sorry guys, you can see that Field of Dreams has been changed to reflect the new values, which is fantastic. So, for some reason, doesn't like doing this in full screen mode. Please forgive my old computer. So yeah, so that's how you update. If However, the thing about SQL is that you have to be careful when you're doing stuff. And if you listen to no other part of this lecture, listen to this. There's no undo in an SQL database. If you decide to update the movies and set the genre to horror and the rating to R, without specifying some conditional statement, it will update the whole damn table that way. Everything will be a horror movie rated R, which is probably not desirable. What you're essentially doing is you're blowing out all of the data in those fields if you do that, which is not recommended. So, when you enter SQL commands, be very careful. Be careful. The same advice applies, of course, to the delete command. The delete command also has no undo function. So, once you have deleted an entry, the only way to get it back is to re-enter it into the database wholesale. Further, the whole drop table thing, since drop tables gets rid of the most data, it's the one you need to be the most careful about. Pardon me. So there's no undo. So it's kind of like RM space star. Just do not ever do that unless you seriously mean to. It's kind of one of these computer programmers are expected to be sufficiently good at it to not have to work. Oh my goodness, my cat is being so cute right now. Yeah, it's computer programmers are expected to know what they're doing, so we definitely give ourselves the tools to screw things up for ourselves royally. So just be careful when you're doing this stuff, eh? So, and we've only got a few more, well, more than a few more slides. So the question, what if we want to use user input inside of a query? For example, we want to search for all movies with a particular rating. This is back in Python, of course. So one thing that we could do is we could bolt the thing that we want inside of, we can use Python to get from the user what type of rating they'd like to search for using the input method, and then sort of manually bolt that into the string that we're executing. This ends up creating a query like select star from movies where rating equals PG. This is fine. What if the user enters a string with a quotation mark in it, however? For example, parental guidance. What we end up with is select star from movies where rating is equal to parental guidance. This isn't a valid SQL query. The quotation mark before guidance ends the string, so it thinks guidance is an SQL keyword, and it causes an error. It causes problems. This is illustrating a problem that we call, what's it called again? Sanitizing input. Thank you. Because basically all it takes is a person who is slightly clever and knows a little bit of SQL to be able to format a input string to a query that extends that query with more code. And once you've extended the query with more code, you have opened yourself up to a vulnerability. So, if the person is a little bit more clever and inputs PG quote or X quote equals X, then what you're doing, the second condition is X is equal to X. This is always true. So what you'll get from this query is everything in the database, and maybe you don't want to show everybody everything in the database. Maybe some of the data is important or protected. This is problem. This is much problem. So this is called an SQL injection attack. When the user input is mixed up into the query, it becomes vulnerable to SQL injection attacks. This, of course, occurs when the attacker can inject their own SQL commands as a string that gets run by the database because you were silly enough to not sanitize your inputs before actually putting them into your query. This can be used to get more data than you intended. It can be used to trick login checks and gain access without knowing a password. It can be used to access data from other tables using join commands, and sometimes it can be used to even modify or delete data. This is bad. So what happens if the user enters the following? PG end statement, delete from movies where X is equal to X. This would, of course, this would delete every entry in the table without actually dropping the table. So the fortunate thing in Python is that the cursor.execute, the execute method, actually will bork out if you try to give it more than one command at once. However, regular SQL will not, so you got to be careful about that. So how about if you enter the following? Drop table movies, semicolon, and then minus minus, which is your start to a comment in SQL. Well, I mean, it's going to drop the whole dang table, which is definitely not what you want. So, especially if you're using execute script rather than just execute, that does execute multiple commands and is therefore vulnerable to this type of attack. It's pretty terrible. So, don't recommend it. This is why you need to sanitize your inputs. And let me just see. There are a couple of, I'll come back to the comic, but there were a couple of very important SQL injections attacks that sort of happened. For one thing, they are actually the #1 security threat to web applications. Many large-scale breaches in data are due to SQL injection attacks. So you remember when in 2012 Yahoo had nearly 500,000 login credentials stolen? That was an SQL attack. There are a lot more listed as well on Wikipedia. So the way to avoid all of this is to sanitize the user inputs by filtering out single and double quotation marks and other prohibited characters. This can be unreliable, but a better one is to structure the SQL queries by using special programming language features that can safely insert user inputs. So when you use the question mark inside of the Python framework of the execute command, that is automatically bound to the subsequent value in a safe way. So there is some automatic checking that the execute command is going to execute in order to prevent an injection attack in being thrust in using your sort of standard string methodologies. Anyway, I'll leave you guys with this comic, which I'm going to assume that since almost everybody is reading this in post, you can sort of pause the video. But no, you know what? I'm going to read it to you in a sarcastic voice, because none of you came to my lecture today except Sydney. Hi, this is your son's school. We are having some computer trouble. Oh dear, did he break something? In a way. Did you really name your son Robert Drop Table Students minus minus? Oh yes, little Bobby Tables we call him. Well, we've lost this year's student records. I hope you're happy. And I hope you've learned to sanitize your database inputs. So there you go. Anyway, test next week, study for the test. Do assignment 9. The semester is coming to a close, which is fun. I don't know. Take her easy, folks.